the circuit shown in figure, which of the following statement is correct? Here it is a circuit, and the options: time constant is 0.25 seconds in a steady state, current through inductance at time t is equal to 0, current through the battery will be equal to this, none of the above. So first of all, let us reduce the resistance in this circuit into a single component. For example, here 6 and 12, both the resistances are connected in parallel. So for parallel equivalent, we have 1 by R is equal to 1 by 6 plus 1 by 12, and on solving this, what we are going to get is 4 ohm. So on replacing these two with the 4 ohm, the new circuit would look like this. Here it is an inductor connected of rating 2 Henry, and here it is another 4 ohm resistance, and then finally it is a battery of 6 volt EMF. So you can see that whatever current will be flowing through the circuit, it will be same for both the resistances, 4 ohm, 4 ohm. So these two 4 ohm resistances are connected in series. So finally we can make this circuit like that. 4 and 4 in series becomes 8 ohm, and then here it is inductor, and in case of inductor rating is 2 Henry, and here it is R 8 ohm, and then finally there is a battery of EMF 6 volts. So now it has become the standard circuit whose time constant is basically L by R. L is 2, R is 8. So time constant is 0.25 seconds. And luckily first option is the same. But anyway, we will discuss the next 2-3 options also for the sake of understanding. So in the next option, you can see that in a steady state, current through inductance will be equal to 0. So a steady state means after a very long time, because theoretically, as we know that current through this circuit is given by this equation, I is equal to I naught 1 minus e raised to the power minus t by tau, where I naught is what? I naught is steady state current. Steady state current value is I naught, and in case of a steady state, the inductor of the circuit start behaving like a zero resistance. As you can see here in the circuit, the current amount in case of a steady state, I steady state, is going to be what? 6 divided by 8, which is 0.75 ampere, and it is when after a long time, because resistance, equivalent resistance of the inductor becomes 0 after a long time, because at time t is equal to 0, the inductor opposes the maximum. It opposes the growth of the current due to the self-induction process. And we know that flux of the inductor is given by phi is equal to Li. Since here you can see that in a steady state, current through inductance will be equal to 0. No, we don't need that in fact. So option A is correct, and here current through inductance will be equal to 0 in a steady state. No, this is not correct, because in a steady state current is going to be 0.75 ampere, and at t is equal to 0, current through the battery will be equal to 0.75 ampere. No, this is not correct. 2, because at time t is equal to 0, the current in the circuit will be 0, and D cannot be the option. So option A is the correct option to this question.